this works. All right. So today we are going to look at this objective here. We are going to have find common units or number of units to compare two fractions. So first we want to start with, can you read this fraction for me?
4.5.
No, look at the number on the bottom.
Oh,
What does this number look like?
Oh, 5.
Okay, so this would be 4 fifths. 4 fifths. So we would read this fraction as 4 fifths. Can you read this one?
3/4.
3/4, and can you read the last one, Leilani?
9, no. Yeah, 9/10.
9/10. So now we want to look at these fractions and we want to compare them. Okay, so what do you notice about each of these fractions? What do you notice about each of these fractions? Yes, Yemeris?
Only 2 of them are less and then the other one is bigger.
Can you give me a little bit more information? What do you mean 2 are less and 1 is bigger?
So 4 and 3 is lesser than 9. So 9 is a bigger number and 3 and 4 is a smaller number, higher.
Okay.
Lower.
Lower number? What do we call these numbers on the top that you just named?
The numerator?
Numerator. So you said when you looked at the numerators, you saw 4 and 3, which are much less than 9. Now, the numerator will tell us how many parts are being used or how many parts are shaded, right? What do we know about the denominators, the numbers on the bottom?
That they're, the whole?
Yes, the numbers on the bottom tell us how many parts make the whole. So when I look at 4 fifths, do I know how close it is to the whole?
No.
How many more do I need to make one whole?
1 more.
One more. When I look at 3/4, how many do I need to make one whole?
1 more.
And when I look at 9/10, how many more do I need to make one whole?
1 more.
So they're all one away from the whole. Now, how do I compare these though?
That add numbers to make it all the same.
So she's thinking we could add numbers to make it all the same. Do we add numbers to create equivalent fractions?
No.
So what math do we do to create equivalent fractions? What strategies do we use to create equivalent fractions?
Minus them.
No, so we're not going to add or subtract them.
Divide.
We can divide or we could
Times.
multiply. Yes, we could. Now, but for today, we're just going to focus on the fraction itself. We know that they're all 1 unit away from the whole, but what do we know about the size of fractions based on the denominator?
That they're like
What do I know about something that is broken into fourths?
that it was a bigger number at first.
Help?
Are you trying to say that we break it?
So we know that in 3/4, this is broken apart into 4 pieces. Okay? This would be broken apart or into how many pieces? How many pieces? 5. How many pieces here?
10.
Okay, so if I were to compare these numbers, and I know that they're all 1 away from the whole, let's think about the size. Okay? So which of these would be bigger pieces?
The
Bigger pieces.
10.
Okay, let's take a look. Okay, so I'm going to draw here for us, I'm going to draw 3 tape diagrams. You can do this on some paper you have in front of you, or you can do this on your desk. And notice how I'm going to make all 3 of my tape diagrams the same size. Okay, so you can go ahead and draw 3 tape diagrams. The first one, let's go ahead and break it apart into 5 pieces. So I'm kind of going to want to know where my midpoint is so that I can draw my lines. Okay? Where's my midpoint? So there's my fifths. Notice 1, 2, 3, 4, 5. The next one I'm going to decompose into fourths. And then this last one I'm going to decompose into tenths, which means I'm going to find my midpoint, and then I'm going to do 4 lines before midpoint and 4 lines after midpoint. Now, which one of these has the smaller units?
The middle one.
Smaller units? Look at the size of the units. Which unit is the smallest?
The 10.
The tenths. So I'm actually going to shade in 9 tenths. I'm going to shade in 3 fourths. And I'm going to shade in 4 fifths. You can go ahead and do this also on your slab. So you said that tenths are smaller units. We have 3 fourths. We have 4 fifths. Okay, so now if we're going to compare our units, let's look at what we have. Let's compare 4 fifths to 3 fourths. Yes,
I noticed that all of them have 1 left.
one is, all right, each of them have 1 left, but what do you notice about the one that's left?
It's like different sizes.
Different sizes. The units are different sizes. So Leilani said that the tenths are smaller. Which one is larger? Yes.
10. I mean, the 4th.
The fourths. So it's further away from the hole. And then we have the 4 fifths. So let's compare. 4 fifths, is 4 fifths greater than or less than 3 fourths? Look at the picture. 4 fifths, using the tape diagram.
Less than.
4 fifths is blank 3 fourths. Here's 4 fifths shaded in. Here's 3 fourths shaded in.
4 fifths is greater than 3 fifths.
3 fourths. 3 fourths. This is 1, 2, 3, 4 parts. Okay? Now let's look at 3 fourths compared to 9 tenths.
That they're
3 fourths is blank the size of 9 tenths.
3 fourths is
it greater than or is it less than?
less than.
3 fourths is less than 9 tenths. Okay? Less than. Now, if I were to put this in order from greatest to least, if I were to compare this from greatest to least, how would this look? Let's go ahead and rearrange these from greatest to least. Which is the greatest? Yes.
9 tenths, and then 4 fifths, and then 3 fourths.
So you're saying 9 tenths is greater than 4 fifths, which is greater than 3 fourths. Do you agree?
Yeah.
Okay? Now we used 2 different strategies. Can you tell me what strategy we used? To compare. Yeah, what are the 2 strategies we used?
We use subtract.
What strategy?
Tape diagram.
We used a tape diagram, a visual model, to help us see the size. And then, what did we do when we looked at each of these fractions? We
did greater than or less than symbols.
but we talked about what?
4/5, 3/4, and 9/10.
And we saw that they were one away from the whole, yes?
Yes.
So we talked about them being one away from the whole. We talked about the size of the whole based on what the denominator would say, okay? So that was just a warm-up for us. That was our application problem. We had to go ahead and compare these fractions. So now let's go ahead and get started into our concept development. So this first question I'm going to ask you, I want you to tell me, okay, which is greater, 1 apple or 3 apples? Which is greater?
3 apples. Yes. I agree.
You agree. 3 apples would be greater than 1. What is greater, 1/4 or 3/4?
3/4.
Okay? Now I want you to tell me, what do you notice about these two things that we just compared?
They're all apples.
So the first one was apples, and the second was fourths. So what do we notice about them?
They both have 4.
Yes?
They both have 3 and 3 and 1 and 1 and 3 on top of 3 makes a hole and 1 on top of 1 makes another hole.
Oh, but let me ask you this, what's different?
The numbers?
So we have 1 apple compared to 3 apples. We know that 3 apples is greater. 1/4, compared with 3/4, we know that 3/4 is greater.
So we're talking about the difference.
Uh-huh.
The difference is that it's actually apple fourths, so it's like in a line.
Apples and fourths, what do we call those?
4th apples.
What do we call it when I have a number and then I have a word?
Word sentence.
Oh, I think you're starting to think about it.
Number sentence.
So what form? I'm thinking about a form.
Word number.
It's not word form. This is not word form. It's not standard form. It's not expanded form. What form are we looking at here?
Fraction?
This one is always very difficult for us. Remember when we talked about unit form? Remember that?
Yes.
And so when we look at this, the units are different. First we were comparing apples, and then we were comparing fourths. So we moved away from an object into some math terminology, some math terms. Okay? So now, let's move and let's think about another one. So after we look at 1/4 compared to 3/4, let's move on to what we just did, comparing different denominators. So I want you to compare for me 1/4 versus 1/5. Spelling. 1/4 compared to 1/5. Leilani, can you come and put the symbol? Do you use your expo? What symbol do you think will go in the middle? Think about the size. Think about the size. So if you need to, let's think about it as a fraction, write it in standard form. Now think about what we talked about in the application problem about the denominators. Just one, choose one. Is 1/4 greater than or less than 1/5? Okay, so then do you think you're gonna need to, which one are you going to change? Because you said 1/4 is less than 1/5, and here you said 1/4 is greater than 1/5.
So this is greater.
Okay, let's think about it. Let's put it on a tape diagram, okay? I want you to go ahead And I'm going to divide this for you. Fourths, fifths. Can you shade 1/4 and shade 1/5? No, 1/4, 1/4, just 1/4. And shade 1/5 in the other box, in the other rectangle. Just one, just one, just one. Okay? So now I want you to look at the size of these that you shaded, and I want you to compare which one is greater.
This one.
1/4. So can you go ahead and you show me the greater than symbol? Greater than symbol? Awesome. And then where we put it in unit form, can you go ahead and also show me? Okay. So, thank you, Leilani. So if it helps you, the reason we learn these strategies is to help you. If you're not sure what it looks like just by thinking about the math in your head, you can definitely draw a picture. Make sure that you label the sizes. It's very important that we label these sizes, and then we can easily compare. All right, so Yamada Leilani said 1/4 is greater than 1/5. So Yamada, if you can help me with this one, and you can do this on your desk while she does it here at the board. Can you come ahead and compare for me 2/4 to 2/6? Okay, so let's make some space. So you're going to compare for me 2/4 and 2/6. All right? So you're going to put the symbol, and then I'm going to ask you to explain your thinking. Think about what we did with her, what helped her to see it before she wrote her answer. So think about the size of the units. Can you go ahead and write that as a fraction for me? 2/4. And then can you write the other one? Are you also doing this on your desk? Can you show me? On your desk? Show it to me on your desk. Now, can you compare this? What do you notice about these two fractions?
They both have 2's.
In the
Numerator.
They both have 2's in the numerator.
They both end with THS.
Okay, so they both end with that THS, letting you know that it is a fractional part of a number, so not a whole number. That is exactly right. But how are we going to determine the size?
This one's bigger and this one's smaller because 4 is just, if you count as your fingers, it's just 4 fingers, but 6 is 6.
Okay, so same thing we did for Leilani here. I'm going to draw for you 2 tape diagrams, and y'all should be familiar with drawing tape diagrams. And I want you to tell me now, after you shade 2/4 and 2/6, I want you to tell me if you still agree with your answer. Do you agree with her answer? That 2/4 is less than 2/6?
No.
Can you label 2/4 for me?
2/4.
And 2/6? All right, so now I want you to look at your answer, and I want you to look at your picture. Do you agree with your answer that 2/4 is less than 2/6? What do you think? Is 2/4 less than 2/6? No, so when we have 6, we're going to have more pieces, which means that they're going to be smaller. So let's go ahead and make that correction. 2/4 is actually bigger than or greater than 2/6. Okay? All right, so we're going to try another one. Okay, thank you. You may have a seat. Awesome job. Okay. Now, let's to give you the answer on this next one, and I'm gonna ask you on your paper to go ahead and work this one out for me. So I am going to tell you that 5/7 is greater than 5/12. I'm telling you it is. I want you to work out the answer for me. Why is 5/7 greater than 5/12? I'm going to give us about, I'll give you 3 minutes to start with. I want you to go ahead and show me a strategy that you're going to use to prove that this is correct. So we're going to take 3 minutes. At 1:50, I'm going to have us talk through this. So go ahead. Prove to me that 5/7 is greater than 5/12. What strategy are you going to use? What strategy did we just use? So what do we call those rectangular boxes? Tape diagrams, yes. So I want you can use that strategy to go ahead and compare. All right, let's see what you have. It's all right. Okay, very quickly. Okay, go ahead and draw your rectangular models. Make sure they're going to be both the same size. Now divide them into. Okay. Here, how about if you sit at that dry desk and work off of that for now while this one dries? All right. How many parts are you going to need to divide this into? No. Look at your denominators. This first one should be divided into how many parts? 10. Yes. And then the other one should be divided into how many parts? Okay, this is what, yes. Let's go ahead and use a pencil for now. Alright. Try and make them equal distance apart. This one's 12? 12, yes. Leave that to me there. No, it has to be the same size as this one. Your tape diagrams have to be identical with. Go ahead and shade in your parts. Make sure, does that bottom one have 12 parts? It's very important that they're the same. Oh, shade. How many parts are you going to shade up here? 5. Okay, go ahead and shade in 5. Now, what did you get? 7, okay, so 5 parts shaded means it's 7 away from the hole. And then here, how many was it away from the hole?
2.
So you can also compare it that way, right? You can look at how far is this number away from the hole. Yes, these are going to be, these are bigger pieces, right? And those are smaller pieces, so you can definitely see that. What did you notice? Hold on, what did you notice?
That they're the same.
They shouldn't be the same.
Both of them are 5.
Okay, they're both 5, but yeah, but how many are left over here? How many more Did you have 12 in this picture? I don't think you had 12 parts.
1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, 1, 2, 3, 4, 5, 6, 7, 8.
So you should only have 5 shaded. So I see 1, 2, 3, 4, 5 shaded. How many more? How far away is it from the hole?
A long way.
How many away though?
7,
So this one is 7 away from the hole. How many away from the hole is this one?
3,
How many?
2. I'm
2. Okay, so let's go ahead and take a look. So using the tape diagram, both of us were able to, I think one a little bit more confidently than the other. And again, thinking about, because when I saw you draw yours, you just were drawing lines. But I want you to consider, like, where is the middle? And use that kind of as a benchmark to go ahead and draw. So I know that I need 7, and I'm going to draw 1 on either side of my benchmark. And then I know that I'm going to need, let's see,
2.
1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay? And now I can move my benchmark from there. Now I'm going to shade in 5 of these. 1, 2, 3, 4, 5. Okay? And then here I know I need 12. So if this is my midpoint, I know I'm going to need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I can see that the 12s, yes, over here, the 12s are going to be smaller pieces. Those are smaller units than 7s. So when I shade in 5 of these, one thing that we looked at and we talked about was that in 5/12, which is this one right here, make sure you're watching, and 5/7, which is this one right here, we saw that 5/7 was only, wait, did I have too many? 1, 2, 3, 4. Oh, I had 8. So even my picture was wrong. Let's go ahead and make that correction. Because it should have only been 2 away from the hole. Did y'all not see that? You didn't see my mistake? I think you were right, Leilani. I only needed 2 on either side. 1, 2, 3, 4, 5, 6, 7. And I'm going to shade in 5 of those. And we saw that 5/7 was actually only 2 away from the hole. So we can clearly see when we compare these Yamadas that 5/7 is greater than 5/12, because 12s are teeny pieces, much smaller than 7s. Okay? Thank y'all. You're doing a good job. First day back into the classroom. How awesome is that? All right, let's look at 2 8s and 4 10s. So you're going to get to do another one for me. Again, using that tape diagram to help you. 4 8s. I'm sorry, not 4 8s. 2 8s, 4 10s. 2 8s, 4 10s. Now, how is this different from the last problem that we had? Over here. How is this different from the last problem we had?
Because
It's a different problem, but how is it different? The last one we had 5/7 and 5/12. Yes.
different sizes and different numbers.
Okay. Can you maybe use a different set of math vocabulary for me?
They're not the same. None of them are the same as like on the top.
The numbers on the top. What do we call those numbers on the top? Help her out. What are the numbers on the top of our fraction? The numerator. What is it?
Numerators.
So she said What's different in this problem is that the numbers on the top are different. Also, the denominators are different. So, whereas this one, we could pretty easily go ahead and compare that. This one, we're gonna have to do some work on. So let's look at our numerators. Can I make a common numerator, a numerator that's the same? Is there any number here in the top that I could make the same as the other?
No. Well, you could take away one of the 2's from the 4's, and then you can have 2's.
Is there something else I could do?
Well,
You could add on to the other 2.
I could add on, but if we're creating equivalent fractions, am I adding?
No.
What did we say we could use? What's
Multiplication.
multiply? So I could actually multiply my numerator times 2. If I multiply my numerator times 2 to create an equivalent fraction, I need to also multiply my denominator times 2.
So then it's gonna be an equal number.
So then it's going to be what? What is this going to be equal to? 4 what?
4 and 10.
What's 8 times 2? 8 times 2.
Oh yeah, it's 16.
It's 16. Excellent. So now look what we have. Did we just create like numerators?
Yes.
The number on top? Now can I compare these?
Yes.
Using what strategy? What strategy did we just use in the previous problem when we proved that 5/7 was?
Tape diagram?
We can use tape diagrams. Take 2 minutes. Go ahead. And then one of you are going to come, or both of you are going to come and show me your thinking. And I'm going to set it up for both of you to come here to the board and show me your thinking. One at a time though, because of the COVID. Alright, Yamaris, you start us on this one. Can you go ahead and divide this one? You're going to use these two, and you come and show us here on the board. And then when you're done, Leilani's going to come and show me on the board what she did here. I see she's already started. Let's get you a marker. A pen that's not. Alright. Okay, go ahead, choose a color. Okay. You can finish yours there so you have practice and you know what you're going to do. She's going to use this one to show me, to prove which is greater than, which is less than.
Which one?
You're on that side, yeah. So stand kind of to the side and then draw your lines.
Which one am I going to do for this one? Which number?
You tell me. You can start with 4/16 and then 4/10, or you can start with 4/10 and 4/16. Let's see what you have here. Okay. All right, don't forget to label your shaded parts for me. No, what's the fraction? So it's not a whole number, it's 4 out of how many? Okay. And then this one is what? So, Leilani, what did you discover? Can you write a statement for me that uses the greater than or less than symbol? So go ahead and compare 4/16 with 4/10. So 4/16, and then you're gonna put whether it's greater than, less than, in the middle. All right, now start with the original fraction, Leilani, because I see that you check that again. Look at what you have on your table. Was 4/16 greater than 4/10? No, there was more there, right? Okay, all right. So can you go ahead and put a symbol here? 4/16 compared to 4/10. She thinks 4/10 is greater than 4/16, or 4/16 is less than 4/10. Now our original fraction though was 2/8. So let's go ahead, Leilani, and have you compare 2/8 with 4/10. 2/8 with 4/10. You don't have to draw this one. We're gonna save this one. You're gonna draw this one later when we do another problem. So 2/8 compared to 4/10 is what? Think about what had to happen. No, just put a symbol between those two numbers. Send that for me. Thank you. Good, because what we had, okay, you're saying that this is the alligator mouth. Somewhere you learned that the mouth is always open to the greater number, yes? Okay, that's good. So what we discovered is 2/8 is equivalent to 4/16. So if 4/16 is less than 4/10, then 2/8 must be less than 4/10. All right, Yamatis, at your best, you may erase, and then we're going to look at one more. We are going to compare 9/10 with 9/10 and 3/4. Okay, 9/10 and 3/4. So this time I want you to think about the fraction. Can I make a related fraction? Are you watching, Yamatis? So we have 9/10 and 3/4. This is similar to the last problem. Our numerators are different. Can I make a numerator that is similar?
Yeah.
By doing what?
You gotta
Multiply.
Multiplying which one of these fractions am I going to multiply?
the 3
Awesome. So we're going to multiply the 3/4 by what?
by 4.
What am I
Oh
going
no,
to?
9.
No. 3 is a factor of 9. 3 times what equals 9? Because we want to make the same numerator. 3 times what equals 9?
3 times. Wait.
3 groups of?
3.
I love how you drew it out using an array on your desk. So she said 3 groups of 3 would make 9. All right, so Leilani, actually you're going to get to draw this time because Yamatis drew the last time. Okay, we know that this is going to be 9/10 compared to 9, what's 3 times 4?
3 times 4 is 9.
Nope, 3 times 3 is 9, 4
Three.
times 3 is? Add one more group of 3 to what you just had on your
12.
desk. 12, excellent. All right, so now these are the 2 that you're going to compare. So you're going to draw here, she's going to draw there. Tape diagrams. So right here, you're going to partition this tape diagram. One you partition into tenths, one you're going to partition into 12ths. you're gonna need 9. Oh, you're doing 12 first? Okay, that's good. All right, shade it for me. Nine. Okay, can you go ahead and label the shaded part for me, please? Okay. So, what can you tell me about another strategy that you could use? I see you use it on your paper. What did you use other than the tape diagram to compare?
Other than the tape diagram to compare is size and like how many spaces away so one away, zero away. So at the beginning what we did I kind of understand it, so what I did was I went back to see what you guys did in the beginning, and then I put it to the one who has less time away, so less blocks away.
Away from the what?
The numerator.
From the? Okay, what comparison sign are you going to put there? What comparison sign are you going to put there?
Y'all better not be having a good time over here. Y'all having a good time?
We are having a good time with the math. Okay. So you're right. So I noticed every time you did it, even when you did it here, you put, this is so many away from, what's that word I'm looking for? You said here, 9/10 is 1 away, and helper, and you said 9/12 is 3 away. From what? Away from what? She said 9/10 is 1 away from what? The what? What is this? What is all of this?
The diagram?
What would go here if I were to label this?
The whole.
The whole. So you used size and distance away from the whole to help you decide if it was greater than or less than. Did you see how she did that? And every time she did it, she did the same thing. So this is the whole. All of this is the whole, but the shaded part is only part of the whole. If you can see how far away it is from the whole, it can also help you with your comparison of these fractions. So today what we did, let's see if we met our objective. We found common units to compare two fractions. So the units that we made common were the numerators. We started with like numerators, and then we had unlike numerators, and we used what? What did we use to make like numerators?
Multiplication.
We did multiplication. We can do the same thing with the denominators. We can create like denominators, and we'll look at that in our next lesson, okay? Thank you all so much. Tell me something, before you started, I want to know how confident you are now that we've done this lesson. So, tell me.
Before I started, my subject, math is not really like something that's,
Easy for you?
yeah, so when I was in my head like, oh, then I have like the accident. So when I was younger, I was so good at math. That was actually my favorite subject, but now that I'm in 4th grade, it's like kind of hard. So I'm like, but like every day I keep learning more, so it gets to me.
Okay, gets a little easier. How about you? Do you think that you, from the beginning to when we ended, do you feel like you understood it a little bit better?
Yeah, because like at first like I wasn't even using those type diagrams. I was just using like lines and stuff, and then like now I know about those, so now I can like start doing it.
Yes, I'm super proud. I noticed even as we did this, that you got more comfortable with understanding the different strategies. How you understood that first we need to make equivalent fractions. You learned how to use these tape diagrams to help you compare. So again, thank you all very much for that lesson. We're going to transition now. We're going to have a break, and then we're going to transition into ELA, okay? Thank you.